आसान से काम. Okay, I introduced in this class some free compilers of Fortran, where you can readily test some of your commands, but that is not the professional way of doing it. Because from Fortran programming, our objective is to develop software-like thing, an application file that can get the input, and it will process the data and generate the user desired output, independent of Fortran, independent of computer system, right? Such a file is application file, like VLC player file. You copy the application file on any computer and you can run it. Similarly, our objective is to develop a software, a device that can do inverse for us, inverse of 1,000 by 1,000 matrix, right? Exponentiation of 1,000 by 1,000 matrix. And they are actually done by the programmers for solving the radioactive decay chains problem, which is very much the problem of nuclear engineering and radiation physics. So right now on this portal, right, online compiler Fortran is there. So I have got the option, and yes, here is the space we can write. Right now, this is not important. Okay. So the fundamental structure of Fortran programs is they begin with the word program, right? Then there are few statements. You can declare the variables, real, integer, and we will also learn we can also declare complex variables, logical variables, and character variables, like the string, sentences, right? Names, something like that, right? With respect to this one, let me log in here. That should be. Well, I have some old files saved in my directory. So let's see one by one, so that to have a review what we have covered so far. So I began with the CF1 file, right? So the first command, I think most of you are familiar with that. Hello world, that is to print a message. So the keyword which is identified by Fortran is the print statement, print asterisk. So we have just used that one, print asterisk. The asterisks whenever appear in Fortran statement, it means work with the default option. That is the beauty of Fortran, that you can work with the default options as well. But that is not the professional practice. We will add specificities to that. Then there is a statement. I used this attribute that write the expression as such, 2 plus 2 equal to, as an answer or as in calculation, it is without quotes, so it is 2 plus 2. Then when I tried 5 divided by 3, so the answer returned was at that time, well, we can test it here. So, okay, this is one statement. This is written in a slightly different way. That is to see what is the difference between the two and how do we work with that. Then we tried the trigonometric functions. There are also a gallery of hyperbolic functions as well. And this ampersand sign, this ampersand sign, that is a continuation mark. If your program statements are long, they cannot be completed on one line. So you can break that to the next line and next line by adding an ampersand sign. It means the statement continues on the next line. Well, this ampersand sign is the specific of Fortran 90 and the recent version, Fortran 95, 2003, 2008, 2018, right? They have their specialties to attempt the parallel computing and the other jobs, right? So in Fortran 77, we do it slightly differently. In Fortran 77, there is a specific convention to work with the columns. So in order to execute the program, we have used this facility, right? So we found the answers, right? Hello world was presented, printed as such, 2 plus 2 equal to printed as such. So something is identified within quotes or double quotes, things are identified as text, right? They are very important. As we have adopted the Purdue University standards for documentation of programs. So you will find there is going to be excessive use of comments and the documentation print statement as well. They are very important. So that you are always informed about the steps you have written in your programs. So the summary of this thing, that there were library functions. There are library functions in Fortran. There are several operations. If I would like to summarize here. So for example, everything followed by the bank sign, that is a comment, right? So there are arithmetic operations identified by plus, minus, multiplication by asterisk, and division by a backslash, and exponentiation by double asterisk. Okay, that's fine. Then there were trigonometric functions, right? We have sine, cos, tangent, and their inverses, right? Then there are hyperbolic functions. Then there are logarithmic functions. Right? So you should be able to identify the structure. In the sine example, in the sine of x example, we found that just writing sine of 30, that was not adequate because the argument should be real. So with respect to functions in journal, the arguments are important. Their type should be identified carefully, right? If you want to use them, and when you will write your own functions in the coming part of the course, so that is something you have to be really careful about. And with the trigonometric functions, the convention is they require the argument to be in radian measure. If you provide a real value, it will return the answer. However, that is consistent with the radian measure of the angle. Since the trigonometric functions are calculated on the basis of trigonometric series function expansion, Taylor series expansion function. So from here, some other facilities. If you want to save this program, so go to these buttons and you have the options that you can work with. So here, save a local file, and similarly you can download, you can upload your own file and you can run it from here. But in this case, even though this is a simple thing, this is very nice. You don't have to go for the column convention in Fortran 77. But this is not going to provide you a facility offline, right? And also it is not going to be a portable program, right? You have to do the compilation step. All the power which is inside this button execute, it is not available to you when you are at home without internet connection. When you are without internet connection, then this facility is not known. But this is very good that you can test your commands with the internet connection, which means if you have internet connection or some mobile data package, so you can give a sacrifice for the sake of knowledge, even though it is very hard to use your cell phones for studying something. It's very hard to dedicate time on cell phones for studying. Right. Well, to work with the compiler, right, we copy the G77 folder from the learning materials, and it is copied here, right? In the folder, we have several further folders, subfolders containing the documentation and library files, right? They are written in a special binary format, so you cannot edit them, but do not delete them. If you delete any of those files, your program will never run. So in this folder, bin folder, we copy our program, we write our program in any of the text editor, and we save the files as a .for extension file. See here, this file is .for. It's a for file for Fortran. This is also a for file for Fortran. And also we have several application files that we developed last time. So for example, if I open this test file, this is going to be opened with the software Notepad++, right? I mentioned that this Notepad++ offers some facility of highlighting the syntax. It identifies the syntax of several programming languages, right? So for Fortran syntax, this is the very first example. So all the content written over here, I have to save it in the directory. By the way, I have opened that one from the directory, so there is no need to save it. Just to give you a feeling that I'm doing something new. Let me write here a new statement. In Fortran 77, our program statements must appear between 7 to 72 column, right? So it's a convention, right? And the continuation character must appear in the column 6, right? So here it is written in column 6. Let me show you where I am working with the facility of Spotlight. So at the status bar, it is showing in which line your cursor is and in which column your cursor is working. So where is my cursor? Cursor is in my hand. Okay, so it is exactly in column 6. So in column 6, you can write a number, right? Which means the previous statement is continued on the next line, right? So let's run this one. In order to run it, we have to start command prompt. So I will write cmd. Right. So cmd is here, but where are my programs? My program is in bin directory. I have to access the same. I have to get to this folder, right? And what I'm doing on keyboard, that will appear over here, right? So bin directory. I will copy this address. Copy. It is in G directory. Right, I can see that one now. So now I'm going to write here G directory. And then I can write here cd. And with the base command, it will be G77 and bin, right? I can also do it by just typing cd and with the tab key, folders will appear G77, and then again with the tab key, bin directory, documentation directory, library, bin directory. Okay. I would like to see the contents of this directory. I would write dir. So you can see here now that all the files which are available here, they are also visible in the command window. So ARAS, and here our files test01.for, test01.exe, pendulum.for. These are the files that I developed last time. Okay, so let me delete the file del test01.exe, right? And I will make now new file. If you want to see here, the execution file is not here for the test01 program. So let's compile it. B77, the file name test01.for, -o is for making the object file, and we will name it test01.exe, which means it is a execution file for test01.for file. So see here, I'm working in the real folder where my compiler G77 is there and my file is there. That is the fundamental requirement. जी अब दोबारा बनेगी इसीलिए की कि मैं now I am working with the new file, right? कि कोई भी Fortran file है, I have a Fortran file, so how to develop the application file, right? So already available file has been deleted, right? So it means the compilation process has been successful. There are no compile time errors, right? So now if you see the folder, there is now a new test01.exe file, application file has been developed. This application file is going to generate the same results as it is going to produce here on every computer that can run Windows program, right? Just like VLC player. So now I'm going to call this file. I would say test01. So all the answers have been repeated here. Hello world, here I am. And sine of 30. And sine of 30 calculated in 2 units would be 0.5, right? In Fortran 77, there is one feature that you can get to a statement by its label, right? So one such example, for example, I write here, go to 10, right? So now in columns, columns 2 to 5, I can write here the label where I want to take the control. So for example, I write here 10, and here I write a print statement, and print statement with a message. You have got to the end of program, right? By doing nothing. So now this program has a statement line, executable statement, print, right? Well, this is not going to do any calculation. This is not really an executable statement. Yes. So this is a message statement, hello world. Then here go to 10. So program will jump to this line, right? And it will only print this message. The rest of the answer would not be generated, right? So, but this program has been changed, so I have to save it. And if I run the test01.exe, nothing has happened. This is the execution of old file. I have to delete the old file. So with the up arrow key, previously I wrote delete 01.exe. Now let's again compile. So whenever you make an update in the file, you have to recompile it. I can get access to the compilation command by the up arrow key. So it is same. So the program has been compiled, and now see the results. The effectiveness of goto statement. The control has been shifted to another line by its label. That is the specific of Fortran 70 and its previous versions, right? So, hello world, you have got to the end of the program, right? So nothing has happened. So that was that was a demonstration, right? So that you can work with the G77 compiler again and again. Right, now let me open the file pendulum. So pendulum.for, last time I wrote that. So there is a program description, and I have defined the variable by myself, right? So description, this program gets the input of length in centimeter, and length is defined as LENTH, length of pendulum. I have defined a variable for pi value, and pi is defined, G is defined. So now I have intentionally defined the length variable as real. So now it can accordingly store. And these are the messages that we, by which we make the programs interactive for our user, right? And then comes the calculation, right? So make use of blank lines and the comments excessively in your computers according to the standards that I have now adopted from Purdue University course, right? So if you are not at Purdue, you are learning like at Purdue, right? We really like Purdue University because our honorable teachers were graduate from that university. Okay, so I delete the old file that was pendulum.exe, right? So the file has rightfully been deleted. Yes, so I have only the working file pendulum.for. Let's compile it all the time, writing compilation command pendulum.for -o and pendulum.exe. The program has been compiled, pendulum, right? Okay, so see the message. See the message, interactivity of the program. This program gets the value of length of pendulum in units of centimeter and computes its time period in units of seconds. Do you like to test it? Please enter a value for the length of pendulum in units of centimeter, right? So kitni de दें और and if I go here, if I press enter, Fortran is going to neglect the blank spaces. It's still looking for the value of length, right? Right, 100. So the answer is 2.0. It's a seconds pendulum, right? So that is very nice. Now, now right here, see the effectiveness of another statement again. Now I'm going to get back to some old point. So now I'm going to write here go to 10. Now what will happen? And let me set 10 here, right? In columns 2 to 7, 2 to 5. So ये 2 to 4 में लिख दिया मैंने. So this is right. There is absolutely no problem. Save the program. Now what will happen now? I'm getting to the top. I have to recompile the program. you do not delete the old executable file, it is going to overwrite that one, right? So no error is there. And now no cry, no sigh, no coughing, no whistle. This is really an amazing program. Please enter a value for pendulum. So 10. Please enter a value of length, 20. So it is now repeating the thing, right? Repeating the things. How many times? We have not specified. We have not specified. So it is going to run infinite times. And if your computer encounters such a problem, such an infinite loop, so the problem to getting out is press Control C. So that will terminate the execution of this program, right? That will terminate the execution of this program. Let me write a brand new program, right? So getting to the column number 7 and right here. Okay. We have got, okay, I have suggested a name test go. It means this program is to test the go statement, go to statement. So I have said test go, right? Okay. Let me save this program. So all the time, save as, it should not be a normal text file. Please be wary that that it should be saved in the bin folder, right? It should be saved as a programming file, not a bash file. So here we have the Fortran fixed form source file, which is truly the Fortran 77 syntax, but I'm going to save it Fortran free form source file so that the text highlighting is effective and available. Already in this folder, there are 2 files of the same type, right? I would say in the name section, I would write test go .for or .f. These are the Fortran file extensions. And now from 7 to remaining column, we have the program lines available. If I write it back, sometimes the highlighting is lost, right? Now I'm going to write here a print statement again. Print statement. I'm here, right? Okay. Okay. So let's save this file and run the program. So we have to compile it. So I would write G77 test go.for, right? Test go.exe. I have not written any documentation, right? So because I am explaining all the documentation, but when it is not a class, you're writing your program in your hostel and you want to deliver that to some person in Canada. So that person is not going to listen to you. That person has everything as your program. For letters, it should be just like a letter. So which says that a letter represents you in your abscess. Your words represent you in your abscess. So your program should be complete in documentation. So let's try it. By the time being, there is nothing like go. So I'm here. It said I'm here. Okay. So what should we do? You are here. What should I do? Okay. Not important. Okay, I'm going to write here a print go to statement. So like I introduced earlier, I would say go to 20. And for 20, I'm here writing 20. 20 in columns 2 to 5. Finally, I write these lines in columns 9, but there is absolutely no problem. So it is going to be an infinite kind of thing, right? So we have seen that we have to crash the program intentionally. So just to write that 5 times. So let's write a counter here. I would write, say, I, which is identified as an integer. So I is 1. So print I'm here. Then let's write here the value of I as well. Print asterisk. That is the first level way of writing the things. Value of I. Okay, let's write here. Value of I 1. Right. And now I'm going to write here I equal to I plus 1. This statement seems to be weird in mathematics. This is not the equation. It means the new value of I is equal to old value of I plus 1. So it means an update of value of I, right? So by 1. And now let me introduce another statement. I would say if I is less than or equal to 5, then go to 20. If I is less than or equal to 5, then go to 20, right? Get back. So I have introduced an if statement, and this LE is for less than or equal to. Up to Fortran 77, we have to use these alphabets LE, but in Fortran 90, you can use the symbols for less than or greater than, that's fine. G77 also identifies the less than or equal to signs, right? So you can write it in that fashion as well. So let's save this program and see what emerges, right? So since program has been modified, I have to recompile and run. I'm here, value of I is 1. I'm here, value of I is 2. I'm here, value of I is 3, 4, 5, right? So a relatively logical, well, very logically and very intelligent use of goto statement, we have run a loop. So now in this loop, if you work with this loop in intelligent way, then believe me, you can solve first order differential equations. You can solve first order derivatives. You can write programs for first order derivatives. You can write the programs to solve non-linear equation in one variable. You can solve the one-dimensional integration problem if you have learned this one intelligently. So now every processing is also possible. The value of I is here. Value of I square will be this one, right? Value of log of I. So whatever calculation that are inside this block, all the calculations which are inside this block, they will be repeated. The real job of programming is to help you out in repeated tasks. So now look for my problem of solving the inverse of a 50 by 50 matrix. Elimination of rows, you require a similar type of process, right? Row operations. And then by Gauss elimination, there are processes which are repeated. So for repeated tasks, we can use the programming language, right? So in today's class, I have not discussed the real content of my lecture. So I have tried to fill in the gaps with you people, right? So just see whether it works or not. Let's go. Now value of I and I squared, right? So see the value of I and I squared. So please